Hey everybody. So for the last couple posts, I've talked about a couple panels that I've built for various aspects of brewery automation, and I thought it would be nice to show the actual result of these automation efforts, especially as they pertain to an actual brew day. My apologies if the photography is a little shaky and kind of Blair Witch-like. This was something I kind of decided to do last minute on an actual brew day. You'll get a peek into some of the bugs I'm still trying to resolve, what's working well and what isn't quite working so well yet. And without further comment, let's get to it. Getting ready to dough in. And we got our Mashin Script ready here. This will read values off of this guy so that we are getting an exact amount of water volume into our grains, so we know for sure what our water to grist ratio is. And go down here, and usually this is pretty good about priming by itself, but if not, I've got a prime valve here. But I can see water up there, so it looks like it's pretty much primed by itself. So let's go ahead and kick off the script. And then we'll hit our target volume. All right, so away we go. Got flow. See the rate on the meter down here, and that matches what we have up here. We've got a gallon count of what we've done so far, and so for this batch we're shooting for target volume of 7.25 to go into the mash. When it hits that, it should automatically shut off. Okay. So I've got the alarm telling me that we've hit our target volume. And turn that off. And Mashin Script is complete. Okay, so back down here. Move this guy to where we're now in recirculation mode. So now we can go ahead and open our mash tun valve. And now we can start up the mash tun recirculation script. Okay, so the step mash script is running. Our mash in temp was pretty close to the target temp for the first rest, so we've already hit it. It didn't take very long, and we're already counting down for the short protein rest, and then it will continue on to the next step. A couple of seconds left on this step, and see what happens. All right, so this one's turned green. The hot liquor tank is now programmed to step up its temp. The pump is turned back on, and we have a recirc rate about a little under a gallon per minute, which is generally what we're shooting for, so we don't recirculate too fast. And once we hit our target temp of 156, this clock will start counting down again for this step. I'm kind of zooming back out to what we have going on here. We have this DC pump, which is how we can control the actual flow rate. We can measure the flow rate coming out of the pump so that we can converge on a reasonable flow rate. We're flowing out from the mash tun into this pump through this flow meter then up into the Hermes coil and the hot liquor tank. And the hot liquor tank temperature is maintained via an electric element. And all this stuff is controlled by this guy over here. These are 3 pumps. And above that, we've got 3 temperature probes, 2 wires for 2 flow meters, kill switch, so outlets for our 2 burners down below. We've got our solid state relays that can turn those burners on and off. And then, of course, as we've been looking at, the user interface for all of this is over here. Pretty fun stuff. And we can take a quick peek what it looks like when it comes back into the mash tun from the Hermes coil exit. You can see we've got some nice gentle flow in there. And mash is almost complete. All right, so that script completed successfully, and now I'm going to run the Sparge script, which I haven't actually run before. So we'll see how well this works. Getting the Sparge to work programmatically is pretty tricky. This is about as slow as I can get it, which is still pretty fast, almost half a gallon per minute. But below that, the pump kind of behaves strangely and does like a pulsing, which I have to debug somehow. It's also kind of tricky to get the other pump exactly matched so that we have a exactly matched fly sparge with equal amounts entering the mash tun, right as the same amount as leaving between the 2 pumps. So yeah, a little bit of work to be done here. I mean, it's working, it's fine, but I'm having to throttle the pumps manually rather than just have the script do it. And I might have a bit of a stuck sparge too, because this is getting slower and slower, which is not a good sign. But yeah, some bugs with a new system. The nice thing is, though, is we're keeping track of how much we're sparging here, so it'll automatically shut both pumps off when we hit our target volume. Okay, so automated sparge is complete, but that process definitely needs some work. I had to manually intervene to get stuff to turn out just right. So I also have a boil script, and I'm taking a stab at trying to reach boiling and then ratcheting the burner down to prevent a boil over automatically. There's a lot of guesswork in this script right now, but I will give it a try and monitor it, and we'll see how it does. Boil start, all right, good. Okay, so when we start the boil script, it sets the kettle element to 100% on. It sets the boil clock to 1 hour. This value is actually pulled down from BrewFather, so it's whatever time you set in BrewFather, and it will import it. And then we have a wait until the kettle temperature is at least 200 degrees, and then the system will automatically bring the element duty cycle down to prevent a boil over. And we'll see how well that actually works in practice. And as we're boiling, we can also get a little whirlpool going just to keep temperatures nice and even in there while we're increasing temperature and helps so we don't scorch anything while we have the burner running on full power. So we're coming out, going into this pump down here, which is dedicated whirlpool pump. And that comes back up into the whirlpool valve. So it looks like this worked. Just starting to see some boil activity, and it registered boil start. It started the clock before we got close to a boil over, so I am pretty happy with that. Looking over at the panel, we can see the duty cycle. Actually see the solid state relay that controls the heating element turning on and off. It's running at a 63% duty cycle right now. And then up on our power meter, lower left-hand corner is amperage being used, and you can see the amps go up and down, and the watts go up and down as the burner turns on and off. Okay, so we're end of boil. I let the kettle get down to under 180, and we can go ahead and dump in our whirlpool additions. Yummy, yummy. About ready to transfer into the fermenter. I transfer over hot and I cool in the fermenter. I do this so I can leave behind hot break and other junk in the kettle. I find that if I don't do that, I tend to extract a lot of astringency if I cool in the kettle. Some of that break goes back into solution, and I find that it's quite astringent in delicate styles. So I do this to avoid that. So I'll go ahead and open that guy up, and we will punch in value for that pump. And so now we are transferring. Okay, we're post-transfer. Switch over to the cold side readout here. So you can see where we just transferred over. It's 147.4 degrees. Obviously, we want to get that a little cooler before we pitch our yeast. So the last part of this process is where I have incoming water to the building. One direction, the filtered direction, is where I fill my hot liquor tank from. And then I've got this guy, which actually runs through the cooling coil for the unitank. But instead of using the glycol system to bring this down, which would be too much for the glycol system, we're just going to use good old cold water, so just like an immersion chiller. And then with the quick connects, I can unhook the water line and then hook up the glycol to it. Yep. Then we have the output, and we can actually walk around. Yep. And I just drilled a little hole through the wall there. There's my exit for the chiller. So this is how I oxygenate. I have this little camouflage that has stone on the inside. It's a 1.5 inch tri-clamp connection. And then we have a ball lock for gas on the other side, so it's kind of nice. We can just hook it onto there. And then over here we've got our oxygen tank with the Blickman regulator. And with that ball lock connection, we can just shove that right on there and oxygenate for a couple minutes and we're all good. Okay, end game. We've got our Kveik yeast to pitch. We now have the glycol system hooked up to the coil. We've oxygenated. And I didn't shoot the video of it, but I dropped a tilt device in there already. And so come over here, we've chilled down to 76. I've programmed a ceiling of 85 and a floor of 75 because it's Kveik. And we're getting readings from the tilt. On the refractometer, I actually measured 1 point less. I've got 0.66 for starting gravity. So we are looking good. Okay, now finally that everything is done, I've pitched the yeast, we're oxygenated. I run the Unitank Controller 1 script, and this script will turn the cooling and heating on and off to keep temperatures in the ranges that I've specified here, ceiling and floor. Right now we're close to the floor. Normally this would be a very high temperature for pitching yeast, but this is a Kveik yeast, so we can do that. And here's the fully assembled fermenter. Added a blow-off tube to a flask of low foam sanitizer down there, just in case it gets sucked up, but that would be a big faux pas if it did. And we've got the temperature probe there, which goes into this guy. And this is actually the first panel I built that controls the cold side of the brewery. I have another video on that. And so that is it. That is a brew day here. So overall, I'm pretty happy with the way this system is working out. I really feel like at this point the main thing I need to work on is the Sparge scripting. Like I mentioned in the video, it's pretty tricky to get the pumps matched just right, and it's really contingent upon how well you can measure the flow rate. And with one of my flow meters, I can measure at a flow rate granularity of 1/100th of a gallon. The other one can only do 1/10th of a gallon. So that causes some issues, and I may actually have to think about a different flow meter to fully solve the problem. And with that said, I think it'd be interesting also in the future to do a video that focused on some of the other equipment involved here, like the two flow meters, the differences between them, and what I would recommend to people buying their first flow meter if they're interested in automating in a similar way. So stay tuned for those upcoming videos, and I'll see you next time.